All right, so today we're going to talk about balancing chemical equations, which we actually sort of previewed in the last video.
A little bit. So balancing an equation, the big thing is you're going to be adding numbers in front of the formulas, and we call those coefficients. And the idea behind this is that you're going to add it to the individual reactants and products so that the same number of each element or atom is going to be on both sides of the equation, so the left and right hand side. And when the equation is balanced, you know it's balanced because the total number of each atom will be the same on both reactant and product side.
All right, cool. So the reason why we do this is because of something called the law of conservation of mass. Now that simply says that matter cannot be created nor destroyed. It can only be changed. So if you have a hydrogen atom there, you can't just magically make it go away.
Nope.
Or likewise, you can't just pull a hydrogen atom out of thin air.
Yep.
Matter is always there, so you need to account for that. And we do that when we balance our equations. So here's a little example. Let's say we have the formula, that's sodium oxide, correct?
Correct,
My
sir.
resident chemistry expert.
Nice.
And H2O is, of course,
Dihydrogen monoxide.
Yes.
water.
Yes.
And then those things come together to form sodium hydroxide.
Yep.
So you'll notice that if you're to add up the number of atoms on both sides of this equation, on the reactant side you have 2 sodiums, you have 2 oxygens and 2 hydrogens, and same on the other side. Okay? So what's going to happen is, you'll normally see a problem where we neglect to put this 2, in front of the sodium hydroxide, in which case it's going to say there's 1 of everything, and that equation would not follow the law of conservation
So
of mass.
it wouldn't be balanced then because it doesn't have
Wouldn't
the
be
same
balanced.
on the reactant side and the product side.
Right, because it would have indicated that, a sodium, an oxygen, and a hydrogen just disappeared.
Disappeared,
and went
yeah,
to
that
nothing.
can't happen.
And that's impossible.
No.
So
We put
that's,
the 2 there, right?
Yep.
To do that.
And
So
that's
you
why
multiply
we
everything by it.
And that's why we why we balance the equation. Sorry,
And
I'm having a hard
that
time
2
talking.
is that 2 is the coefficient, right?
Yes, so that was the next thing I was going to.
Right.
So
Sorry.
remember, your coefficient, the thing you're changing, is the number in front. You're never changing something within the formula itself. So you
So
can't just
leave
write
it
a
alone.
2 inside the sodium hydroxide.
No.
That is impossible to do. You need to just only change coefficient.
So you're changing the compound
Cool.
there.
So
if
here
you
are a few
have that,
simple
then
rules. Oh,
that's-
sorry, go ahead.
I was going to say, so if you give that a click, then we can say that guy is balanced. Now let me go over a couple little rules here, guys. These are, and I shouldn't even say they're rules, they're guidelines. In general, here's the easiest way I've found, or we've found, to actually balance these things. First thing, as Mr. Karnstedt alluded to, is do not change the chemical formulas. Really do not absolutely at all ever do
Never!
Never!
Never.
He's going to hold him back. He's going to go off on you guys. Don't change the chemical formulas on those, the little things in the boxes. We can't do anything like that.
It would be like adding an extra arm to your body.
Can't do it. The other thing is, make sure right after you do that, you've isolated your chemicals. Maybe you can put boxes around them or circle them. Count up all the atoms on each side. Count them up on the reactant side. In our little equation down there, you can see we got 2 hydrogens and 1 oxygen. On the product side, we have 2 hydrogens, 2 oxygens.
Ruh-roh.
Hydrogens are balanced. Oxygens are not balanced. We got a different number there, so that tells us right now we got to balance these guys. So let's go on to step 3.
Because
Because we can't
this
just
oxygen
create
didn't
an
just come
oxygen out of nowhere.
yeah.
You can't just create matter.
And we know that because of the law of
Conservation of mass. It's got to be there in the beginning and at the end. So the next thing you're going to do is adjust the number of atoms on each side as you need to by adding coefficients. And remember, coefficients are the big numbers we multiply by in front of our atoms or our compounds or chemicals, whatever we have there.
Like the big 2s and
the big
one.
green 2s and 1s. Now that we've put those in there, let's step to the last little thing we don't have to worry about here too much because it's all hydrogen and oxygen. But I want you guys to remember when we get in the classroom, generally we are going to balance all the other chemicals first, and then we're going to take a look at hydrogens, and then usually oxygens even last. So, and if you look at that now that we've added coefficients, the numbers we had are no longer correct. Our new numbers show that we have 4 hydrogens and 2 oxygens on the reactant side, 4 hydrogens and 2 oxygens on the product side, which means it's now balanced. And if you look at that, H2 times 2 is 4.
I was going to say, is that how you got the 4? The
Yep.
2 times the 2? Okay.
And the
I feel like we've been
1
working on this
oxygen
in
yeah,
class.
that
times
sounds really
2.
familiar. I'm just saying.
Yep, so we've done a little bit of this, haven't we?
Yep.
All right.
Cool.
And as you should be, we'll work with this, but you should be changing your numbers as you go through it.
Yeah, you're going to have to do this a lot. This is definitely a pencil process. Do not use pen for this.
No, you'll get really annoyed.
It's not going to work. We can't do it in pen. You're going to go through this, and you're going to add some numbers and multiply the stuff in, and then you're going to see that something else changed and have to go back and do it. It's a process. It's not just to do it real quick.
All right. That's it for today.
Good to go.
And out.